Find a possible solution for f of x given that f of x equals integral of x sine of x dx. Okay, so this will be an integration by parts problem because we can tell one of them will go away and substitution just isn't going to work. So I'll start by writing out the formula for integration by parts, which is the inverse of the product rule. I know it might feel like this is in poor use of our time by rewriting the deriving the integration by parts every time from the product rule, and it might be, some people out there are smarter than I am, but I am not smart. Therefore, I derive it every time, and it just keeps me from making, therefore it's one simple mistake I will not make. Whoop. Okay, I make lots of mistakes, plenty of them simple. But when I derive the integration by parts formula, I usually catch my mistakes, which is good. And so I'm able to self-correct and get the correct answer more often than not. Okay, so now we have our formula. We'll write up I late, inverse, logarithmic, algebraic, trigonometric, exponential. We have an algebraic and we have a trig. Algebraic takes priority over trig. Therefore, we'll say that u equals the algebraic one, which in this case is x. So u equals x dv, which is right here, that's dv, v prime, equals sine of x, v equals cosine of x. Okay, now this is where I kind of have to take a step back and look and see if this makes sense. So, got to make sure I get the right sign here. So we have sine as an S-I-G-N, not S-I-N-E, or S-I-N, which not too worried about. Okay, so if we take the derivative of cosine, we're going to get negative sine. So the integral of sine will be negative cosine. Okay, so the only one I actually remember is that the derivative of sine is positive cosine. And then everything else is, and then cosine is opposite of that. Okay, so then we have du equals dx, 1 dx. Put everything together, and we get, this always seems, integration by parts seems to be a lot of setup for a small amount of actual algebra, which I don't mind, by the way. Okay, so we have negative x cosine of x minus integral of cosine of x. I'm going to put the negative out here for ease dx. Is that true? V du. Yep, I'm good with that. So we have negative x cosine of x minus sine of x plus sine of x. So let's see here. So if the integral of cosine of x equals sine of x, then the derivative of sine of x going the opposite direction should be cosine of x, which is true. Derivative of sine of x is positive cosine of x. So I got the sign correct on that. Is that everything? I think that's it. That's the whole problem? I think that's the whole problem. Yes, and it's even right here, right here. This is the one. That is the answer. So they switched them over. Whoop. Backwards and forwards. So we have sine of x minus x cosine of x. That's not too bad. That's not too bad at all. I even feel good about myself. I feel good. Good for me. Good for me. Okay. Backtrack. Integration by parts. We have our formula. Write down the formula. We derive the formula like so. We then determine what we want our u to be, what our dv to be, because we have a u dv. I wrote here as v prime, but it's basically dv. And then the cues that we had that this was going to be integration by parts is we have one function, x, that goes away if we take the derivative of times. And then we had sine of x, which does not go away if we take the derivative of times. That's kind of the cue. Plus substitution wouldn't work for this because you don't see one thing that's a derivative of the other. Okay, that's how you solve this problem. That's the kind of thought process. Thank you much. See you next one.